Hello everyone, good afternoon. My name is Sofia Silva and I work at Cinti, the Center of Nanotechnology and Smart Materials, as the team leader of the Functional Fibers department. Today, I'm here to present the Text Beyond project. This presentation is entitled Textile Structures from Biopolymers, and this project is under developed with Tintex Textiles, the project coordinator. First of all, I will start to do a brief presentation of Cinti and Tintex. Then I will present the Text Beyond project. Concerning Cinti, our shareholders are composed by three universities: University of Aveiro, Minho, and Porto, and by three companies: CITEV, the Technological Center for the Textile and Clothing Industry of Portugal; STIC, the Technological Center of Leather; and SEIA, the Center of Engineering and Products Development. Our competences are founded under three main pillars: functional materials and solutions, smart materials and systems, and design and engineering. We work with many industrial sectors. However, our three main targets are the automotive and aeronautics, architecture and construction, sports, health, protection, and well-being. Our philosophy can be described in three steps, starting with the research and development, where is presented the proof of concepts, going through the prototyping step that includes the product design, and finally, finishing with the pre-series and co-production with the product's market proof. We also work with several substrates as paper, cork, polymer, ceramics, textiles, and so forth. Our trademark is Nano for Industry. This represents our mission, that is work directly with the industry. Now, just a brief review about our competences. As I said before, we are divided in three main pillars. First one, functional materials and solutions. Under this pillar, we are capable of develop nanoparticles and nanocapsules. Also, we can do the surface functionalization of many substrates given several functionalities as easy and self-cleaning, drug release, thermal management, antimicrobial, and so on. Under the same pillar, we are capable of develop polymeric compounds and polymer coatings. Also, we develop multi-component fibers, up to 3 materials within the same filament. These fibers can be doped with nanomaterials. Still, within the fibers production, we can produce advanced fibers based on cellulose. Second pillar is composed by printed electronic and lighting, where our skills and expertise allow us to construct printed electronic circuits and sensor actuators under flexible substrates. These substrates also can be stretched without being damaged. Previous printed sensor mentioned can be integrated onto non-conventional and flexible substrates. Additionally, we can develop the hardware and software related to these sensors on a mobile app format. At last but not least is the third pillar, the product development of prototyping and pre-series. Our approach starts from the conceptual design to the products, comprising pre-series and market test manufacturing. Now I will do a small introduction and presentation of Tintex Textiles. Tintex was born in 1998 on the north region of Portugal and currently focuses its works on the dyeing, finishing, and coating of knitted fabrics. Tintex's mission is to be able to develop responsible textile solutions that can be easily distinguished by their design innovation and sustainability, and can be also maximized by emphasizing through cooperation, knowledge, transparency, and fashion. Their vision is to be able to build a new generation of textile solutions that can be truly supported by their eco-sustainable strategy. Now I will present what brings me here, the Text Beyond project. Text Beyond is a national project founded by ANI and IAPME Institute, with the coordination of Tintex Textiles and participation of Cinti on the research and development of this project. The focus of Text Beyond is the development of textile structures from synthetic fibers that are made from organic thermoplastic polymers that can be used in Tintex conventional textile process, and furthermore be dyed and finished with Tintex eco-sustainable process. For this project development, we create 4 research and development lines. The first one on the R&D of bio-based polymer compounds. The second one on the R&D of textile fibers from these bio-based polymers. The third one is focused on the R&D of the textile structures that can be developed using this biopolymer. And finally, the fourth one consists on the R&D of the natural dyeing process applied to the developed textile structures used to study biopolymers. Starting by the research and development of bio-based polymers and considering the specific case of biopolyethylene and PLA, we study the additivation of these polymers. For the case of biopolyethylene, its additivation was conducted for affinity proposals between polymer and dye. And in the case of the PLA, its additivation was accomplished for process stability reasons. Here are presented 2 pictures of the additivation performed. Nevertheless, and involving the second phase of R&D, we considered that the additivation conducted on biopolyethylene was not successful, and just PLA went to the second phase. In the second phase, and considering the production of textile fibers, we developed a monocomponent fiber with these 3 different polymers: biopolyamide, biopolyethylene, and PLA. These textile fibers were used in spinning of yarns that were then used on the Tintex conventional knitting machines. Here, the textile fibers and yarns developed were used and the most simple textile structure was developed, a jersey structure. After developing the previous mentioned textile structure, we conducted a research and development for its dyeing. The starting point was a natural dyeing method patented that is owned by Tintex Textiles. This method presents lower environmental impacts. This process is a salt-free dyeing and it is possible to obtain several different natural colors. For the presented project, we use 5 different natural extracts. Finally, and considering the industrialization step, here we have 2 different pictures that depict the industrial use of Tintex patented natural dyeing process. In this case, was used 2 different fabrics, one of cellulosic origin and the other one of synthetic origin. Yet, for the case of this project, we weren't still able to do it at this level. Nevertheless, we were able to do it very successfully on a balanced scale using around 1 to 2 meters of knitted fabric. We are very proud of the obtained results. Here we can see a picture of a textile structure developed using biopolyamide and dyeing using Tintex natural dyeing process. Thank you very much for your attention. Here are my contacts, so feel free to contact me directly if you have any doubt. Thank you very much.